Welcome back to All This Math. And on this particular video, we got the ancestor, the late Kwame Ture, formerly known as Stokely Carmichael. He's with us, as you see on this t-shirt that I'm wearing. This is Kwame Ture, one of the greatest Pan-Africanists to ever live. A graduate of Howard University, but before that, was born in Trinidad and Tobago, like many other great African freedom fighters, and grew up in New York City, and was a member of SNCC, Student Nonviolent Coordinating Committee, and was a important fixture in the civil rights movement, as well as the Black Power movement, before repatriating to the continent of Africa and continuing his life's work of working toward liberation for African people all across the globe in the country of Guinea, along with Kwame Nkrumah and Sekou Touré and many other brothers and sisters on the continent and throughout the rest of the planet. So I just want to shout him out since I got this t-shirt on. And if you're not familiar with the late Kwame Ture, please do yourself a favor and do your research. Do your research on Kwame Ture. Check out his book, one of his books, Black Power, co-authored with Charles V. Hamilton. Also check out his autobiography, Ready for Revolution. There's also another book of speeches that he delivered through the 1960s and 1970s entitled Stokely Speaks. I highly recommend Stokely Speaks. Definitely recommend. I recommend anything, that the brother, published or, was reflective of the work that he did for our people that still benefits us to this day. So, today, on this video, we're dividing fractions, doing some more work with dividing fractions. So, we see behind us, we have -2/7 divided by -4/9. So, we're dividing two negative numbers. So, as we should know, whenever you divide two negative numbers, we already know what the sign of our answer is going to be. Our answer is going to be positive. Our quotient, because that's what we call the answer when we do division, we call that a quotient. Quotient. We call that a quotient. When we divide two things, we get a quotient. We don't get a product. We get a product when we multiply. We get a sum when we add. We get a difference when we subtract. All right? When we divide two numbers, we get a quotient. And when we divide two numbers that are both negative, our quotient is going to be positive. It's going to be positive. So think of it like this. With multiplication and division, two wrongs make a right. That might be a little device that you can use to help to remember that, right? So, what we're gonna do here? All right, so I got two fractions and I'm doing division. Typically, what we do is we do this method. See this up here, KCF. That stands for keep, change, flip. Keep, change, flip. That means I'm gonna keep this first fraction when I rewrite the problem, right? I'm gonna keep this first fraction, it's -2/7. I'm gonna change my division sign into a multiplication sign. I'm gonna change my division sign into a multiplication sign. Then I'm gonna flip the second fraction and make its reciprocal, right? That's what we do when we take a reciprocal. We basically flip it. So the 9 is gonna go up top, the 4 is gonna go down to the bottom. So this is gonna become, instead of -4/9, it's gonna become -9/4. Now, conceptually, what this problem is actually asking us from the beginning is, how many 4/9 can fit into 2/7? How many 4/9 can fit into 2/7? All right. Now think about that. I know my answer is going to be a proper fraction. This is why. I know that 4/9 is almost a half. 4/9 is almost a half because 4.5 is half of 9. Think about that. I know that 4/9 is almost a half because 4.5 is half of 9, and this is a 4, right? Right, which is close to 4.5. And I know that 2/7 is less than a half, right? Because 2/7 is like, if this was a 6, that'd be 2/6, that'd be 1/3, right? So this is less than 1/3 because when the denominator gets bigger, the fraction gets smaller. So 2/6 would be 1/3, 7 is bigger than 6, so I know that this fraction value is less than 1/3. I know I just said a whole lot just now. If you don't fully understand it, don't feel bad about that. Don't feel bad about that. I'm going to have some other videos on the channel where I specifically talk about some of these concepts with fractions and how we can better understand fractions and how do we kind of manipulate them and how we can, deal with them in terms of, real world everyday applications. So don't even worry about that. But anyway, what I'm trying to get you to see is the fact that this fraction is bigger than this fraction. this is more than this. So if I'm saying, okay, well, how many of something that's bigger than something can fit into something smaller, that means that the whole thing can't fit because it's too much. This whole thing can't fit into this. It's going to be too much. So that means that only a fraction of this can fit into that. So that's what we're about to figure out. How much of this can fit into that? Because we already know this whole joint can't fit into that. We already know that because it's too much. Because this is more than that, right? This is more. So the whole thing can't fit, but some of it can. So we're about to find out how much of it can. That's what we're doing when we're doing division. And whenever you're doing math, I want you to make sure you understand the algorithms, make sure you understand the procedures, but I want you to always also try to think about why it works and why it makes sense and what the concepts are that are embedded within the work that you're doing. Because then you'll be able to say, okay, well, since I understand the concept, now in my everyday life, when I encounter situations, I can relate it to these math problems that I do, and I can actually use math as a valuable tool and apply it in my own everyday life. I don't gotta just think about, well, I don't gotta just think about, well, how can I do it for my homework? Or how can I do it, when I'm taking a test? No, math is a tool put here for us to be used in any and every situation. We just have to know how to recognize when it can be used, right? So that's what I'm trying to put you on to. I'm trying to I'm trying to show you the concepts of what's going on when we're doing division with fractions. So that way something will resonate with you, and then you'll see other situations in your everyday life where you're like, oh, yeah, that makes sense, because we was doing the math, the fraction problems, and yeah, this relates to that. So always keep that in mind. So let's go ahead and do the keep, change, flip. So we're going to keep the first fraction, which is -2/7. So I'm going to just rewrite that, -2/7. I'm going to change my division sign to a multiplication sign. I'm going to use an X in this problem, right? We can use an X, a dot, an asterisk. We use parentheses. We got a lot of options. The -4/9, we got to flip that. Meaning we got to take the reciprocal. The 9 goes up top, the 4 goes down the bottom. So this is going to be -9/4. And now we have a multiplication problem. Now we got a multiplication problem. So now, and I'm going to do my multiplication vertically. I'm going to come down here with it. I'm going to come down here with my equal sign. Now I'm just multiplying horizontally. Now I could cross cancel. Matter of fact, I'm going to cross cancel. Let me talk about that a little bit. Cross canceling is when you basically reduce your numbers diagonally. You reduce your numbers diagonally if they have a greatest common factor that's not a 1. Meaning, what's the biggest number that can divide or multiply evenly into both of these? It's 2. 2 can multiply into 2, and 2 can multiply into 4. The question is, how many times? How many 2's can go into 2? 1. So this 2 turns into a 1. How many 2's can go into 4? 2. So this 4 turns into a 2. Now this works diagonally, and it's called cross-canceling. Cross-canceling. That's what we just did. We cross-canceled. Now the 9 and the 7, the only common factor 9 and 7 have is 1. Right? So we can't do nothing with that. All right? We can't cross-cancel 9 and 7. So now we can do our horizontal multiplication. Now we do 1 times 9, which is 9. And we do 7 times 2, which is 14. And the answer should be positive because I got a negative times a negative. I had a negative divided by a negative, but that converted into a negative times a negative. And whenever we deal with two negatives with multiplication or division, our product or result is going to be a positive. All right? And we got 9/14. My next question is, am I done? How do I know if I'm done? I know if I'm done if I can't reduce. If I can't reduce this, I know I'm done. So I got 9/14. I can't reduce it because they don't have a common factor. There's no number that can multiply into both of these or that they have in common. There's no number that can multiply into both of these besides 1. 1 is the only number that can multiply into both of these. 3 can go into 9, but 3 can't go into 14. 2 can go into 14, but 2 can't go into 9. Not evenly. We're talking about evenly, right? We're not talking about with remainders or decimals or none of that. We ain't talking about all that, right? Evenly. 7 can go into 14 evenly, but 7 can't go into 9 evenly. All right? So that means that we done because we can't reduce 9/14 no more. We can't. All right, so this is our final answer, or our quotient to the original problem. All right, so like I said, if you never heard of Kwame Ture before, or you just heard his name but they don't know too much about him, go check him out, go do some research, go down that rabbit hole, you know, check out some of his writing, check out some of his work, learn about the brother. He's got a lot of lectures on YouTube from the 1990s, right? 1990s, 1980s, he even got some stuff from the 70s. You know, some audio lectures, maybe a little bit of video footage from the 1970s. But check that brother out. It's very important. One of my greatest influences. Influenced me so much, I named my youngest son Kwame after him. Just goes to show you. All right? Now, until next time, go get some practice.